So you can see various things here. First of all, try to see milk, okay? Then you see a pan, then you see grapes, okay? Some of them have fermented, and then you can see chicken being cooked. Then you have the digestive system, and finally you can see a girl here breathing. So you can see these are various processes, right? Like, let's consider milk is being kept for a long period of time. It will change, okay? It won't be as fresh as it was at the beginning. Similarly, a pan, we discussed rusting. It happens to iron and corrosion to other metals like copper and silver. So when a pan will be kept, it will also change its characteristic. Then when we go to grapes, they will be fermenting over a period of time. For chicken, when it is cooked, the raw chicken and the cooked chicken or meat or anything being cooked, the taste differs, of course, because you add a various things, then you add heat most importantly. Then we have digestive system. This food, let's consider this food, when we try to eat, when it goes to our stomach, it gets digested. So again it changes its characteristic. And finally you can see this woman breathing, which is why we are shown respiration, the process of respiration, where we are taking in oxygen and leaving carbon dioxide. So you can see in all these 6 pictures there are processes occurring and a change occurring. The nature and identity of the initial substance changes, okay? When a chemical change occurs, a chemical reaction takes place. So in all these things, as I discussed, the initial thing is transformed to a different thing. Somewhere oxygen is being transformed to carbon dioxide. Somewhere you can see there is a pan, it's being rusted. Somewhere the characteristic is being changed, like for milk. So everywhere there will be a certain difference, and that can be termed as a chemical reaction. A change is occurring because of the chemical reaction. So this can be actually seen through various examples, which I will be bringing forward to you. First of all, this is the magnesium ribbon, okay? You can see this is being burnt. Now you can see a dazzling white flame coming out of it, okay? So initially what it was, it changed its characteristic. Now a dazzling white flame can be observed, right? So magnesium ribbon burns to form a white flame and a white powder also. Powder was not displayed, but after some time it will be actually giving us a white powder also, which is magnesium oxide. It is actually magnesium oxide. It occurs due to a reaction between magnesium and oxygen present in the air. So you know air has oxygen, we all know that, and I already told that it is a magnesium ribbon. So that magnesium and oxygen, they actually form a reaction and form magnesium oxide. Okay, magnesium and oxygen together form magnesium So together they form magnesium oxide, which has a characteristic of this, which will be giving us a white flame, white powder. So that is what actually occurs, and you see this is a chemical change taking place, which means there is a chemical reaction taking place at the beginning, which we can't like see the chemical reaction in that sense. We can just see the after product. The final product is a dazzling white flame and a white powder. That's what we can see. So now a question for you. Magnesium ribbon burns to form a white flame and white powder, which is what? We have a dash. Option A is magnesium nitrate, option B is magnesium oxide, and option C is magnesium sulfite. The correct answer is option B, magnesium oxide. See, it's very simple. You know that oxygen is present in the air. So oxygen in the air and magnesium ribbon it is, they are forming together a component which will be definitely magnesium oxide. Nitrogen or sulfide is not relevant here, okay? Now going to the next example. So here lead nitrate is being put in potassium iodide, and you can see a yellow color. You can see the color is differing. Initially the two mixtures, once more see it, they look like water, they are colorless. But once you put it, it's changing its color, it's turning into yellow. Now let's explain it. In this reaction, the lead ions from lead nitrate combine with the iodide ions from potassium iodide to form insoluble lead iodide. So this is what actually occurs. The lead nitrate and potassium iodide together form insoluble lead iodide. Okay, again a mixture. This precipitates out as bright yellow solid. Okay, so it forms a bright yellow solid. You can see, like as I told, reaction you can just write on paper, but the byproduct of that, like it's changing its color, it's changing into yellow. I just displayed it. Here we can just write it, but you saw the display also. So the other product, potassium nitrate KNO3, remains soluble in the solution. So one product remains soluble in the solution, the other product comes out as a bright yellow solid, which you saw in the previous example. Okay. Now going for another example. So here are some zinc granules. Okay. Zinc granules will be put in different test tubes and we will be taking dilute H2SO4. Okay. So it can be dilute hydrochloric acid. You can do it with sulfuric acid also. It should be diluted and it will be put like this. So you can see there is a change occurring. It's moving, and it's not just the physical change. There is something else also happening, which I will be explaining further. So you can see. Now, a colorless, odorless gas with bubbles evolves. So you can see the bubble, but again, it's a colorless and odorless gas, which is why I said you can't see the entire physical change because a gas is evolving. Okay, so you can't see it completely from here. The zinc metal turns from silvery gray to black. That also you could observe, and the test tube becomes warm. So the first 2 points mainly, you can see colorless and odorless gas and test tube becoming warm. Only if you physically perform the experiment you can understand that. But from here you can understand the physical changes, that is silvery gray to black, and then bubbles are evolving. All these things you can actually infer from the picture itself. So the whole point is that there are certain changes occurring when there is a chemical reaction. Okay. Now, finally, summing it up, a chemical reaction takes place if we observe there is a, okay. So there are four things, if they are observed, you can actually infer that there is a chemical reaction taking place. First of all, change in state. We saw the state is changing in many cases. Then change in color. Okay, you saw how it became yellow in the second example. Lead nitrate made it yellow. Then evolution of a gas for the third example, and also change in temperature in the third example. We talked about how the test tube became warm. Okay, so once these changes occur, you can be sure that there is a chemical reaction taking place. Okay. Now, summing it up, what are the three examples? You can see this is the entire summary, but let's try to connect it with the three examples. First of all, we took the example of the magnesium ribbon. So magnesium ribbon gave us, when it was burnt, it gave us a dazzling white flame. Okay, it was the first example, dazzling white flame. Later we concluded that it also becomes a white powder after some time. Then we came to the example of lead nitrate being put in potassium iodide and it became yellow. So it was also a change in entirely the color of the liquid. Okay, and finally we came to the example where dilute hydrochloric acid or sulfuric acid also you can use was put into zinc granules. And it changed its color, it changed its, actually it gave us bubbles also, silvery gray to black the color changed, it gave us bubbles, and finally it's an odorless, colorless gas, and also it changes the temperature. Like the last thing you can see, it was not found in other two examples. Okay, the last point, change in temperature, it didn't occur in the first two examples. But in this example, the temperature also changed. Like we don't know how much, but the test tube became warm as it was mentioned. So you can see in the three examples itself, all these four criterions, change in state, change in color, evolution of a gas, and change in temperature. All these four occur in all the three examples. You can actually perform more experiments but perform them safely. Okay. So these are the takeaways from this video.